So in polar world, the area bounded by R equals to f of theta, while your theta is bounded between A and B, is A equals to, here we have a half integral of f of theta squared d theta, theta ranges between A to B. So if we have polar equations, and then we're interested in finding the area bounded by those equations, we have to follow the formula, a half integral r squared d theta. R is just f of theta, so f of theta squared d theta. For example, find the area enclosed by one loop, of the four-leaved rows, which is defined as R equals to cosine 2 theta. Okay. The very first step is to graph this guy. Step 1, graph R equals to cosine 2 theta. You can use your table, use an online website to graph this guy, and the graph is like this. So let me graph this here. We have 4 leaves. And the question says, very nice and symmetric. All of these needs to be symmetric with the same. I have that. So the question says, what is the area of one of these loops? Just one of them. Let us select this guy on this side. So let us find the area of this loop on this side. This is the loop that we are working with. So we want to know what is this area. Okay, so we have a formula. The formula says here you have A, step 2, use the formula. A is equal to a half integral A to B R squared. So here you have cosine squared of 2 theta d theta. But what is A? What is B? How do we find these two? Well, R is equal to cosine 2 theta. At the origin here, your R is equal to 0. So take a look at this. When R is equal to 0, it means that cosine 2 theta is equal to 0. So cosine of 2 theta is 0. It means that 2 theta is equal to pi over 2, or theta is pi over 4. Because of symmetry, you have pi over 4 and negative pi over 4. Negative pi over 4 to pi over 4. Now, I expect you to ask, well, this shape is symmetric. So why not just finding this little area here and multiply by 2? Of course, why not? So A can be written as 2 divided by 2, integral 0 to pi over 4, cosine squared of 2 theta d theta. Again, since you have exponent 2, you have to convert that using half an angle. So here you have integral 0 to pi over 4. Here you get 1 plus cosine of 4 theta divided by 2 d theta. Okay, the rest is what you learned in elementary calculus. Here you have theta divided by 2 plus sine of 4 theta divided by 8, 0 to pi over 4. Again, I'm not too worried about pi over 4 and 0 because I have sine. Sine of pi is 0, sine of 0 is 0, so this pi is 0. What I'm worried about is the first term, which gives me pi over 8.